Welcome back to MindSpark, Science Now, the podcast where we explore the most mind-blowing frontiers of science. Today, we're rediving deep, literally, into one of the most extreme and awe-inspiring events in the universe. What happens when two black holes collide? Imagine two invisible giants, each born from the death of a massive star. They roam the cosmos, silent and dark, warping space and time around them. Now picture them being pulled closer and closer together by their own immense gravity, until ... Boom, not a bang we can hear, a ripple across the fabric of the universe. That's not science fiction, that's real astrophysics. So let's break it down. First, let's get on the same page. A black hole is a region of space where gravity is so strong, not even light can escape it. They form when massive stars collapse at the end of their life cycles. Some are only a few times the mass of our sun. Others, supermassive black holes, can be billions of times heavier and live at the centers of galaxies. But today, we're refocusing on binary black holes, pairs of black holes orbiting each other like cosmic dancers. Over time, black holes in a binary system spiral inward. Why? Because of something called gravitational wave emission. They lose energy by sending ripples through space-time, like waves on a pond when you throw a stone. Only these waves travel at the speed of light and were predicted by Einstein back in 1916. As they orbit faster and faster, the gravitational waves grow stronger, ... until the moment of truth, the collision. So what actually happens when they crash into each other? Merger. The black holes coalesce in a fraction of a second, forming a new single black hole that's more massive than either of the originals, but not quite the sum of their masses. A few solar masses worth of energy is released as gravitational waves ring down. The newly formed black hole wobbles like a struck bell and quickly settles into a stable shape. That final ringing also sends out gravitational waves. No light, but lots of waves, unless there's gas or matter nearby. The collision doesn't produce light, gamma rays, or X-rays, just those invisible, all-powerful gravitational waves. On September 14, 2015, scientists at LIGO, the Laser Interferometer Gravitational Wave Observatory, made history. They detected the gravitational waves from a black hole merger 1.3 billion light-years away. Two black holes, about 36 and 29 times the mass of the Sun, collided and formed a 62 solar mass black hole. Where did the missing 3 solar masses go? Into gravitational wave energy, and we felt that tiny ripple here on Earth. This was the first direct confirmation of Einstein's predictions and earned a Nobel Prize in Physics in 2017. You might be wondering, why should we care? Well, black hole collisions teach us. Asterisk how black holes form and evolve, how gravity behaves under extreme conditions, and possibly even hints about the very origin of the universe. Plus, it's a new kind of astronomy, not with telescopes, but with gravitational wave detectors. Like LIGO and VIRGO, these observatories let us hear the universe in ways we never could before. And guess what? It's just the beginning. In the next few years, space-based observatories like LISA will launch. These instruments will detect lower-frequency gravitational waves and observe supermassive black holes colliding across galaxies. We might even learn whether black holes obey the same physics as everything else, or if they hide something more, like clues about quantum gravity, dark matter, or even new dimensions. When two black holes collide, it's not just a cosmic crash. It's the universe whispering its deepest secrets through ripples in space-time. We're lucky to live in a time when we can finally listen. Thanks for joining me today on MindSpark, Science Now. If you enjoyed this episode, don't forget to subscribe and share it with a fellow stargazer. And remember, the universe is not only stranger than we imagine, it's stranger than we can imagine. Until next time, keep wondering.